Now we have seen the examples of chlorination of alkanes. Now we are going to see examples of bromination of alkanes. Like chlorination, when alkanes undergo bromination in presence of ultraviolet rays, then here also the tertiary hydrogen atom, the hydrogen atom which is bonded to tertiary carbon atom is reactive than that of hydrogen atom which is attached to primary or secondary carbon atom. Now we are going to see the reaction. Now this is first example, CH3, that is ethane. Now when this ethane is treated with bromine molecule in presence of ultraviolet rays, then you will get here ethyl bromide, that is CH3 CH2 Br plus HBr. Now here this is symmetrical molecule, therefore we will get only one product, that is bromoethane. Now second example, this is propane. Now in propane, this carbon atom is secondary carbon atom because it is attached to another carbon atom, and this carbon atom is primary carbon atom which is bonded to only one carbon atom. Therefore when it undergo bromination, then we will get mixture of two products, in which first product is CH3 CH2 CH2 Br, that is 1 bromopropane. And second product is CH3 CH Br CH3, that is hydrogen atom from this carbon atom, secondary carbon atom is replaced by bromine, then we will get CH3 CH Br CH3. This is 2 bromopropane. Now here percentage of 1 bromopropane is only 3%, and percentage of this 2 bromopropane is 97%. That is major product is obtained as a 2 bromopropane. Percentage of this product is 97%. Then third example, now this is butane and butane. All carbon atoms are in a straight chain, therefore it is N-butane. Now when this compound undergo bromination in presence of ultraviolet rays, then here we will get two products. First is CH3 CH2 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 Br. This is 1 bromobutane, that is hydrogen atom from primary carbon atom is replaced by bromine, and if the hydrogen atom from this secondary, now these two carbons are secondary carbon atom which are bonded to another carbon atom. Now this is bonded to these two carbon atom, and these two are primary carbon atoms. Now if the hydrogen atom from secondary carbon atom is removed, then you will get CH3 CHBr CH2 CH3. This is 2 bromobutane. Now in this case, this 2 bromobutane is a major product, and percentage of this product is 98%, and percentage of this product is 2%. Now I take next example. Now in this case it is 2-methyl propane. Now here 1, 2, 3, 2-methyl propane. Now here this is tertiary carbon atom which is bonded to 3 carbon atoms. Now these are primary carbon atom which are bonded to only one carbon atom. Now when this compound undergo bromination in presence of Br2 molecule and in presence of ultraviolet rays, then here if hydrogen atom from this primary carbon atom is removed, then you will get here CH3 CH3 CH2 Br, and second product is CH3 CBr CH3 CH3, that is hydrogen atom from this tertiary carbon atom is removed, replaced by bromine. Now here mixture of these two product is formed. This is 1 bromo 2 methyl propane, and this product is 2 bromo 2 methyl propane. Now here this product form in traces, that is in a very small amount or in minute amount, but this is percentage of this product is above 99%, that is here 100% this product is obtained. In this way bromination of alkane is carried out, in which the hydrogen atom which is bonded to tertiary carbon atom is easily replaced by bromine. Now this halogenation of alkanes is a free radical formation reaction. That is here this halogen molecule, that is X2 molecule, undergo homolysis, that is symmetrical breaking of a covalent bond. Now here this X2 molecule undergo homolysis like this, in such a way that each bonded atom retains its bonded electron towards itself to form an halogen atom or halogen free radical. Here formation of halogen free radicals takes place. Now we are going to see the free radical mechanism of first type of chlorination of methane. Now it undergo or it is carried out in two steps. First step is initiation. Now here this chlorine molecule in ultraviolet rays undergo homolytic bond fission or homolysis. And when homolysis is carried out, the equal distribution of this bonded electron pair takes place in between two chlorine atoms to form free radicals of chlorine. Now these are the free radicals of chlorine. Now this free radical of chlorine undergo propagation with methane molecule. Now here also this methane, the CH bond in methane break in homolytically or it undergo homolysis. Then this formation of CH3 free radical, hydrogen free radical, and this hydrogen free radical get attached to this chlorine free radical to form free radical of methyl group, and here HCl is formed. That is this free radical of hydrogen get combined with the free radical of chlorine to form HCl. Now this CH3 free radical, then it combined with free radical of this chlorine. That is this chlorine molecule undergo homolysis or homolytic bond fission, and this free radical of chlorine get attached to this CH3 free radical to form CH3Cl plus Cl free radical. In this way, this is the mechanism of chlorination of methane or first step of chlorination of methane. This is first step, that is formation of methyl chloride. Then this reaction is carried out simultaneously. Then this methyl chloride is converted into dichloromethane. Dichloromethane is converted into trichloromethane, and trichloromethane is converted into tetrachloromethane. This is the mechanism of first step of chlorination of methane. This is free radical formation reaction in which chlorine and methane molecule undergo homolytic bond fission. Second reaction we are going to see is combustion of alkanes. Now here, when alkanes are heated in presence of air or in presence of dioxygen, then here these alkanes undergo oxidation to form carbon dioxide and water molecule with evolution of large amount of heat. Now here this reaction is exothermic reaction in which large amount of heat is given out. Therefore it is exothermic reaction. Now here first we are going to see the example of methane. Now when methane is heated with air, now air possesses oxygen atom, oxygen molecule. When methane is heated with air, now we know that in air there is presence of oxygen molecule, and when this methane is heated in presence of air or in presence of oxygen molecule, then it undergo oxidation to give carbon dioxide, that is CO2, and two molecules of H2O with evolution of minus 890 kilojoule per mole of heat. That is, heat of combustion of this reaction is minus 890 kilojoule per mole. This is highly exothermic reaction in which heat is given out. Now in case of second example, if butane, that is C4H10, is heated with oxygen molecule, then here formation of 4 molecule of carbon dioxide and 5 molecule of water. Now here the heat of combustion of this reaction is minus 2875.84 kilojoule per mole. Now this negative sign indicates this is exothermic reaction and large amount of heat is given out. Now in case of, in general, that is, this is alkane, that is CnH2n plus 2. When this alkane is heated with 3n plus 1 upon 2 oxygen molecule, then here formation of n numbers of carbon dioxide molecule plus n plus 1 H2O molecules plus evolution of heat is carried out. Therefore, these alkanes are used as a fuel, or these alkanes are used as a domestic fuel. You know the example of liquid petroleum gas which are used as a domestic fuel. Now third, pyrolysis. Now pyrolysis is nothing but the decomposition of alkanes. When alkanes are heated in absence of air, then it undergo decomposition to form lower alkanes or alkenes or alkynes or hydrogen. This process is known as pyrolysis of alkane. Now we are going to see the example. When hexane, that is C6H14, is heated at about 773 Kelvin temperature, then it undergo decomposition in various ways, in which first, when it undergo decomposition at 773 Kelvin temperature, then here formation of C6H12 plus H2. This C6H12 is nothing but hexene. Now in second, if this hexane undergo pyrolysis at 773 Kelvin temperature, then we'll get C4H8, it is butene, plus C2H6, that is ethane. Or here formation of C3H6, now it is propene. Or C2H4, that is ethene, plus this is methane. That is, when this alkane undergo pyrolysis or when they are heated in absence of air, they undergo decomposition to give lower alkanes. That is, lower alkanes means the substrate or reactant alkane have 6 carbon atom, but here the alkanes or alkenes formed during the reaction are lower. That is, they have less number of carbon atom. Now in case of this, here formation of hexane takes place with removal of one H2 molecule. Now in case of this, here formation of butene takes place with ethane molecule. Here propene plus ethene plus methane is formed. That is, here this hexane undergo decomposition to give alkane, alkene or alkyne or hydrogen. But this alkane, alkene and alkyne have less carbon atom than that of hexane. Last reaction of alkane is reforming. Now here reforming means formation, or it is aromatization reaction in which straight chain alkanes having 6 to 10 carbon atoms are converted into benzene or its homologues on heating under 10 to 20 atmospheric pressure at about 773 Kelvin temperature in presence of catalyst like vanadium pentoxide or dichromate, or in presence of molybdenum oxide and supported with alumina. Now these are dehydrogenating reagents. The reaction involves simultaneous dehydrogenation and cyclization. Now what is meant by dehydrogenation? Removal of H2 molecule is called as dehydrogenation reaction. Cyclization, that is, open chain alkanes are converted into cyclic compounds. Therefore this reaction is also named as cyclization. Now here, when straight chain alkanes having 6 to 10 carbon atoms are converted into benzene or its homologues when heated under 10 to 20 atmospheric pressure and about 773 Kelvin temperature, then in presence of some dehydrogenating reagents or catalyst like vanadium pentoxide or chromate or dichromate or molybdenum oxide supported with alumina, then the reaction involves simultaneous dehydrogenation, means removal of hydrogen molecule, and cyclization. For example, now here this reaction is known as aromatization or reforming reaction. For example, now this is N-hexane, CH3, CH2, 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 CH3, N-hexane having molecular formula C6H14. When this N-hexane is heated in presence of vanadium pentoxide at 773 Kelvin temperature under 10 to 20 atmospheric pressure, formation of benzene takes place with removal of 4H2 molecule. This is called as reforming or aromatization process. By using this reaction, straight chain alkanes are converted into benzene or naphthalene. Last point from alkanes, uses of alkanes. Now here the first four members, that is methane, ethane, propane and butane, are used as a fuel for heating and cooking purpose. For example, CNG and LPG. Then second, CNG or petrol or diesel are used as a fuels for automobiles. Third, lower liquid alkanes are used as a solvent. Then four number, alkanes with more than 35 carbon atoms, that is tar, that is alkanes having more than 35 carbon atom are known as tar, and these tar are used for road surfacing, that is to prepare tar roads. 5 number, waxes are higher molecular weight alkanes which are used to prepare candles and carbon black. This carbon black is used to prepare ink or black pigments. These waxes are also used as a lubricants. Thank you.